Stats 2023. This is Chapter 8, Section 3. This is still two sample testing, but this is dealing with dependent samples. First two sections dealt with independent samples. First section being the z-test when sigma is known, independent samples. Second one when sigma is unknown, t-test. So what happens here is this is really the t-test for the difference between means. So what this really is a before and after type of problem. First of all, a couple of formulas you need to understand is D, which is the difference, is taking each data point from the first sample and subtracting its corresponding second data point from it. So we have to do this for each data point. When we do that, we take the sum of our D's and divide by n. That gives us our difference mean. These type of problems, the samples must be random, samples must be paired, must be a normal distribution, and data must have at least 30. So that's our central limit theorem again. All right. Okay, here's our problem that we're doing from the text. This is example 1 on page 439. It says a shoe manufacturer claims that athletes can increase their vertical jump heights using the manufacturer's training shoes. The vertical jump heights of 8 randomly selected athletes are measured. After the athletes have used the shoes for 8 months, their vertical jump heights are measured again. The vertical jump heights in inches for each athlete is shown in the table. At alpha 0.1, is there enough evidence to support the manufacturer's claim? All right, so if we look at the chart, the first column here, or I should say the first row, represents the measure of the vertical leaps or jumps without the shoes. The second column represents the vertical jumps in inches after using the shoes. So think about it. If there's an increase in vertical jump from the shoes, we're always taking the first set of data points and subtracting the second. So if I subtract the first from the second, if there's an increase in vertical jump, this second set is going to be higher. So a negative value tells me that the shoes increase their vertical jump. So what's going to happen here in these problems, this is a lot of calculator work on these problems. So the first thing we're going to do is we're going to go stats and we're going to go edit. And you can see what I've done here is that first set of values, the vertical heights before using the shoes, is in list 1. Then its corresponding value after using the shoes is list 2. And in these type of problems, you've got to make sure you match them up correctly. So what I'm then going to do is I'm going to move over and highlight list 3. And what I'm going to do is I'm going to go second 1 for list 1, subtracting second 2 for list 2. So what I'm doing is I'm taking my first set of data points and subtracting the second data points from it. When I press enter, it gives me my difference. Now, here's where we start to use this calculator a lot, because now what we've got to do is we've got to calculate our mean difference, our D bar, and then we got to calculate our standard deviation for the difference. So what I'm going to do is I'm going to press second mode to quit out of here. And I'm going to press math. Then I'm going to move over here to, oops, wrong one. Sorry about that. I'm going to press second stats. And then I'm going to move over to math. Now, look at what the menu for math gives me. Number 3 is the mean. Number 7 is the standard deviation. Those are the two values I need. So I'm going to hit number 3, and I'm going to tell the calculator I want the mean for list 3. Close my parentheses, hit this, and I get negative 1.75. So my D bar is negative 1.75. Then what I'm going to do is I'm going to do that again. I'm going to hit second, stats for list. I'm going to move over to math. I'm going to hit number 7 for standard deviation. And I want the standard deviation of list 3. Close my parentheses. There's my standard deviation. I'm just going to round it to 2.1213. Now, that's the only 2 values I need because I've got n, because n is just 8, because that's how many values that we had. So these are the 2 values that I need right here. Okay? And notice also here, for my null hypothesis, and whenever you're doing these, the difference is always going to, the null hypothesis is always going to be greater than or equal to, less than or equal to 0. The alternative hypothesis is going to be the less than, greater than, or not equal to 0. So, you know, in these type of problems, because we're doing a difference between a before and after, the null hypothesis is going to be, and the alternative is going to be based on a 0 difference. Notice that the claim is the alternative, because if the difference is less than, remember what I talked about before, because if they got a higher jump after than they did before, then there's going to be a negative value for that difference. Okay? So then what we're going to do is we're going to go to stats. We're going to move over to test. And we're going to do our z-test, which is our second one, because we only got one set of data, the difference. So now we want to make sure we put stats. So your u sub 0 is always going to be 0 for a difference, unless it defines a difference. My x bar, which the calculator is calling x bar, is really my d bar. And it's negative 1.75. My s sub x is really my s sub d bar, which is 2.1213. My sample size is 8. My alternative hypothesis is less than. So I'm putting here. And now what I'm going to do is I'm going to hit the down arrow, keep coming down here until I hit calculate. I get calculate. Notice I get t as negative 2.3 repeating. I get p as 0.026. Okay. With p being 0.026 and alpha being 0.1, p is less than alpha. So we reject null and we can support the claim, meaning that the manufacturers claim that the shoes increase an athlete's vertical jump. It supports it. A lot of calculator work on this. Just remember that you're always putting that first row of numbers in list 1, second in list 2, and then you're always going to list 3 and doing list 1 minus list 2. And then you're taking that list 3 and you're going to go to second stats for list, move over to math, and if I move over to math, went too far. You're going to see I can calculate my mean and my standard deviation from that, list 3. Once I get those are the only 2 values that I need to do my hypothesis testing.